going to present my 7th practicum COA here. Let us dive into the practicum. The first step, the first base is the algorithm to analyze the catch behavior. The first step is to define catch and initialize. We are choosing a small catch size which is 4 slots, and after that we are creating an array to represent the catch, and after that we are to the second step, which is preparing memory access sequence. We are creating a list of memory block numbers that stimulate however few accesses memory. Example 0415042663, and after that we are applying direct mapping formula using catch index is equal to block number mod catch size. This will tells you where the catch memory should memory should go in the block, and on the fourth step, which is to check catch hit or miss. If the block is already calculated, the catch value, so it will determine as hit, whereas if it doesn't determine the value, it will take out the value as miss and replace the block at the next index, which is the sequential one, the next one. On to the fifth step, which is display for each memory access. It will display as the block number, the catch index, whether the catch is hit or miss, and the current state of the catch. And after that, it will repeat for all the memory accesses till the last one. And let us dive into the actual procedure which we have used. We have on the MATLAB software in the computer, and we have created a new script file and entered the given values to determine the output. So this is the example code which I have occurred with the catch size which I took is 4 slots, and memory access is 127, and total catch misses is mostly it's miss initially, and after that catch fills it gradually, and after that the few hits observed within it, which depends on repetition. So let us dive on to the results. The MATLAB simulation shows memory blocks are mapped to catch using the direct mapping technique, and catch hits occur when the required data is already available in the catch, which reduces the access time. More like basically it saves time up. And catch misses occur when the data is not present in the catch, and it should be fetched from the main memory, which causes the execution time to be enlarged, which makes basically a delay for the execution. And onto the result part, which is interpretation of results part, which indicates that catch memory significantly improves system performance by reducing memory access time, and direct mapping is responsible for it, but it's also simple and fast, but it also may lead to conflicts when multiple memory blocks are mapped to the same catch location. And onto the conclusion here, this practicum demonstrated how direct catch works and how it affects the performance of the system, and basically catch memory helps in faster execution by storing frequently used data, and direct mapping technique is used to implement in simple cases, but it may cause collisions. Understanding catch mapping techniques can help design efficient processes and improving computing speed. So this is basically overall an explanation how catch memory works using direct mapping method, and there you go. This is the overall this is the related practicum questions, and Uh, yeah, this let's have a glance here. Explain how cache memory improves computer speed and real world applications. In gaming, CPU constantly uses physics, AI logic, and frame data, and so on. So predict what happens is too small. If cache memory is too small, cache thrashing occurs, and industries use different mapping methods, which are as follows: direct mapping, fully associative, set associative, and frequent caches can cause latency spikes, like real life applications such as video streaming or online classes. And